because differentiating x plus 3 is 1. Right, so in this case it remains the same.
这个是五行这个，I'm right 一样的。我不会。
Okay, next we look at try 10. Okay, we look at the different applications. Okay, we are given that there's a curve that has equation y equals to e to the power 2x minus 1. And the interval that we're looking at is from 0 to 3. Part 1 wants you to find the equation of the tangent at the point A where x equals to 0.5. Okay, how do we find the equation of the tangent?
Differentiation. I didn't hear the question.
What do you mean how to find? The equation of the tangent. Tangent at where?
Tangent x.
And x equals to 0.5. Sorry, dy dx. So dy dx equals to what? 2e. Okay, to the power 2x minus 1. Alright, so this will give us the gradient. So when at x equals to 0.5, we'll be able to find out what is the gradient. So that will actually be equals to 2. Okay. Then after that, what next? We want to find the equation. How do we find the equation of the tangent? We got the gradient ready.
0.5 into the
So sub it into the equation e to the power 2 times 0.5 minus 1. So therefore that will be equals to 0. Right? Wait, 2 no, 2 no. Or 1, right? 2 to the power 2 minus 3 so 1. Okay?
It's 1.
1, right? Okay. So therefore the coordinates at that point A will be 0.51, and then after that we can find the equation. So the equation of the tangent will be y equals to 2x. Okay, then for part 2, we are told that the rate of change of x is 0.4 units per second. We want to find the rate of change of y. Meaning to say that we want to find dy over dt.
2 times 0.4.
Huh? What did you just show?
2 times 0.4.
2 times 0.4. Okay, why is it 2 times 0.4?
Because 0.4 is x over dt.
Okay, so this is dx over dt. So we need to have dy over dt times dx over dt. Sorry, dy over dx times dx over dt. Right? So therefore that will be 2 times 0.4. Okay, because what we have over there is when at x equals to 0.5. So therefore the rate of change of y when x equals to 0.5 is 0.8 units per second.
Shut up. This noise.
I got roasted. I got burnt like go. I know, me was injured.
Today our teacher Valentine's Day. Oh, I
Happy. Huh? Not happy too.
you just say it's not happy, but
Eh, later Hannah should come ah.
you don't say so.
Tak tak tak.
Don't call me so.
I'm pretty sure that
They don't bet lah.
Oh.
Hello.
Never wear just
Okay, so in try 11, we are given this curve and then after it has the equation y equals to e to the power of x minus 3x. Okay, we are told that the curve cuts the y-axis at a point A. We want to find the gradient of the curve at A itself. Alright, so how do we do that? How to find? Differentiate the curve, right? So dy over dx equals to what? What is it equal to, Benjamin? Dy over dx equals to?
we find the coordinates of it. No wait.
Huh? E to the power x minus 3.
Oh wait.
Okay, then after that, we want to find the coordinates of A. Alright, so since it cuts the y-axis at A, so that means when x is equals to 0, we will be able to find out the coordinates of y, or the y coordinate. Okay, so then after that, dy over dx would be equals to 0 minus 3, 3. So the gradient is negative 3. Actually, do we need the coordinate? No need, right? No need. So this one. Okay. Sorry, 1 minus 3 is how much? Negative 2. Sorry, right. Okay. Next part 2, given that B is a minimum point, okay, find x coordinate of B. We adjust this diagram. Okay, so if it's a minimum point, what does that mean? So your derivative equals to 0.
So are we gonna use logarithm?
What do you think?
Yes.
Of course, right? There's no other way around it, right? Okay, so we have to use our logarithms.
Ln 3 equals to x. Did I remember that correctly?
So x is equals to ln 3. Okay, you could leave it in a decimal, or you could leave it in exact form. Is perfectly fine. Okay, but of course, if the question wants it to be exact, then leave it ln 3 now.
Is that part 3?
Yes, there is a part 3.
Oh, that's yeah, I know.
Oh, they don't like.
Yeah, so.
Oh, that's so strict.
Okay, hence we want to find out what is the second derivative at B itself. Okay, so the question actually did say that the b is a minimum point. So definitely you will expect the second derivative to give you what kind of value? More than 0 value, right? Okay, so please make sure that the question is consistent with your answer, just in case you make any mistakes in your calculation. Okay, so the second derivative would be equals to e to the power x. Okay, and then when x equals to ln 3,
don't need to do that.
let's see what? To what?
When you have to do x inside because it's already given x, ex equals 3.
Huh?
The ex equals 3.
Then oh, okay. So yeah, I mean you could see that e to the power x equals to 3, so this is naturally going to be 3. Okay.
Huh?
I mean in part 2 you notice that e to the power x is equals to 3 already, right? So over here, second derivative is e to the power x. It will surely be 3 also. Okay? But if you don't understand,
when x equals to ln 3.
yeah, when x equals to ln 3, e to the power x is equals to 3. So now, when e to the power x, and then when x equals to ln 3, e to the power x will be equals to 3. Yeah. Okay? So, that's the answer. Okay? I think I'll just end here. Alright, we still have about 2 more questions I want to go through for 17.2. Then tomorrow we will go into 17.3, which is rather short as well. We may just end chapter 17 tomorrow.
Like 2 chances of that.
Oh, what's wrong with being fast?